Welcome to workshop number 4, which is metal forming part 1. And in this workshop, first thing we're going to do, we're going to cut some metal because you can't form it unless you cut it out of some sheet. We're dealing with sheet metal today. We're not dealing with plate, we're not dealing with I-beams, we're not dealing with solid square stock, we're dealing with sheet metal. And exactly what is sheet metal? Sheet metal is metal that's less than 1/10 of an inch thick. And it's usually not in a super hard condition. It's usually a half hard or a soft condition. And we work with that to create bodies and lightweight parts. So, now to cut sheet metal, it's best to wear gloves. Now these are just some run-of-the-mill rawhide palm gloves, very common, very inexpensive, plenty of these lying around the shop. You should wear these because the edges can be very sharp. These are my personal mechanic gloves. They have leather palms, they're lighter weight on the back. I pop for these myself just because I like a little better sense of feel than I get with the industrial gloves. So I put that on so I don't slice and dice myself. You should do that too because safety is always priority 1. Now, in front of me I have 3 hand cutters. I have a red handle one, a green handle one, and a blue handle one. The blue handle one, if you look at the jaws, are straight jawed. The red handle one have a safety latch on this. When I open them up, if you notice there's a cut, serrated jaws on these, and it has a curve to it. These are designed to cut left. The green ones are designed to cut, let's see, right. Yeah, they go in a right-hand position. I'll demonstrate that here in a moment. So, with these, you can make basic cuts in sheet metal. So if you want a straight cut, you use straight cutting shears. These are hand shears. These are called hand shears. And you go right straight across in a smooth cut. But you notice you have to stop and re-grab it. Stop and re-grab it a little bit and all the way to the end. Now, the only downside with this is it's not so much on these because these have very smooth, polished blades on the straight cut. They don't leave too rough an edge. However, with these little darlings, these have serrated edges and they have very stiff jaws and they're designed for turning when you cut. So here, I will make a little arc, put them back, that's turning to the left, these are turning to the right. And FYI, notice you have these little indexers, these little hilts. The one that's most forward is thumb and index finger. The index finger and the middle finger straddle the second one. That gives you the best grip. That's where you choked up on it and you've got leverage. So these are cutting to the right. They have a hook in the blade that allows them to turn one way or the other. So there you go. Now, this is mild steel. Now if you look, this little rectangle was cut out with some hand shears, and you see these little dimples along these edges? That's because some pliers, not as sharp as these, basically stopped and started, stopped and started, stopped and started. They leave a slightly rough edge that you can work down later with a hammer, but it's never as perfect as an absolute smooth, seamless, one-stroke cut. Now to do that, you have to use a shop tool. And that shop tool, this is called hand shears. There's a shop tool called foot shears. They're operated with the foot. We have one in this room. And here I've scribed a straight line on this piece of mild steel. I'll take it over and we'll cut it on the piece of shop equipment and we should get a nice, perfectly straight line. For larger pieces, larger panels to fit a body or cover a hole or do whatever, make a box, you want nice straight edges. You don't want stop, start if you can help it. Stop, start's fine for little plates and covers, but you can cut long pieces, but you'll tend to have a wavy line. It's best to do it with a piece of shop equipment to give you the longest possible seamless cut. All right, we're over here at this foot shear. Here's the foot bar, which actually brings down the blade and shears the metal off. This is a guillotine type blade, and the blade is on a tilt, and the high side is this end, the low side is that end. Normally, you would insert metal on the low side, and then it comes down at an angle and it slices across. This is an older machine, and it's had lots and lots of use, so this side of the blade is dulled out somewhat. So I find I get much cleaner cuts to come to the back side over here where the blade is fresher. So you insert it carefully. You can actually look between the yellow piece and the green piece, and that way you can look straight down on the edge. Then you slowly lower the blade down till it just touches, and then you stand on it. You heard the piece fall off, and there it is, right along the line. Now, I just hand aligned it. I didn't bring it against. There's a nice square edge over here, so you can get a nice square cut. I'll take a piece of small aluminum here that has a factory edge on this side, and we will insert it against the squaring bar here, and we will clean up all of this dirty edge on this. We will cut this off. Now, one thing I do not want to see is two people jumping up and down on this bar trying to cut material that's too large for this piece of equipment. Just about every kind of shop tool has a plate on it that has its serial number and other pertinent information, and especially on a machine like this. Here you have one that says capacity 16 soft steel. That means 16 gauge soft steel is the thickest, hardest material you can put in this thing. Put out anything else in there, you will bend it, spring it, it will be useless. If you put in a thick 1/4-inch piece of plate, jump up and down on it and do all like that, all you do is tear up the equipment. It's designed to do a family of metals, and that's all. So let's see if we can clean up this edge on this very thin piece of aluminum. Okay. Nice, clean, perfectly straight, square edge. Very nice. Actually, I want to cut a little bit more off of this piece because we're going to use it in another machine later on to show you how to do something special. Okay. Put my metal back. These edges are very sharp when they're freshly cut. You reach through. Get the piece you just cut, and that's all there is to a fit shear. Again, do not overstress the machine by putting in material that's too thick or too hard for it to cut properly. All right, in the other room, we saw how to cut a straight line using a foot shear. In this room, this is 137, the machine shop, and we have two machines here. They belong to Ted, the machinist, and you can't just come in and use these things carte blanche. You have to get permission to use these. But this one is called a brake, and it lies into break over, and it's designed to bend a straight line in sheet metal and very accurately. And the way it works is you have this jaw here, and you have this big knob here, and this lever controls clamping and releasing that jaw. So you release the jaw, you put you some marks on your sheet metal, you feed it in the machine, and you bring the jaw down. And when it grabs on your marks, you lock it down, and then these lever arms here pick this up. This is hinged, and you slowly and steadily, because the metal is being tortured right now, you bring it up to a 90-degree or 45-degree angle, and then you release. You can actually check this with a protractor to make sure you have a full. Then you go back to your black knob and you release, and you have a perfect flange. If we do it on the other side, here again, have little pencil marks. Insert it, gently lower the jaw to the pencil mark. Make sure you have them both. Lock it down slowly and smoothly. Don't snatch, because that can crack the metal. You want to move it smoothly in a smooth motion. Bring it up to the 90 degrees, and you have to bounce it a little bit sometimes to get it to take a set. There we go. You have to go a little bit further because there's a certain amount of spring back, and you release it. Now we have a tray. Nice and stiff, has flanges. If we could have relieve these corners and we could bend it across here, you can even form a box with this machine, provided you can get the part, it's large enough to get the part and maneuver it around. Here again, if you look on the machine, capacity 16 gauge mild steel, that means soft. So you can use 16 gauge aluminum, mild steel, but hardened stainless steel, hardened tooth steel, that's a no-no. Cast, you can't do that. So this is your sheet metal brake, as into brake over. And that's what's used to bend straight line creases in sheet metal, flanges. And it's just that simple. Now, the second machine, this gives us a nice straight line, but what if we want to curve metal in a simple circle? Let's say we want to make a cylinder. That's what this machine is. This is a 3-roller slip roller, and I would imagine it has the same 16 gauge capacity. The way this works is that you have a crank handle, you have these 2 rollers are geared together. There's a 3rd roller on the back, that's the idler wheel. It also has adjustment scales on the idler wheel to raise it and lower it. So basically you insert a piece of sheet metal into here. You can actually set, see these knobs here? You can actually set the pinch on the sheet metal with these knobs. And you want a little bit of pinch so that as you crank the handle, the drive roller will move the metal through the machine. This back roller moves up and down. If I move the roller completely down, the metal just passes through, and the pinch on the roller just thins the metal a little bit and stretches it. But if the roller is up a little bit, the sheet metal is going to hit it and be forced up. And as it's being stretched by this roller and forced up by this roller, it will go into a cylindrical shape. Now, by adjusting the height of this, you can create a hoop. You can just keep adjusting the roller by raising it and make it turn more and more until you actually can close the hoop. So I haven't even checked the setting on this, but it looks sort of good. So let's just see what we've got. I'm cranking it through. Now it's hit the back roller. The back roller's too high. I'm going to have to lower it. Actually, I had a little cringe there. Let me lower the roller down. There's knobs on the rear back here. The roller was set a little high. I'm going to lower it down to, I think that's 10 millimeters. And that's quite common. Now, this is valuable to be able to form metal in a circle because you might need a cylinder because you might need to make a tank. And it's perfect for that. Okay, it's engaged the back roller and it's turning up. Okay, so it put a little bit of curve in it, but not much. Now, I'm checking now the pinch on these. It's a little bit too much pinch, I think. So we'll try it again. Feels a little better. Now I'm going to raise that rear roller, and as you raise it, it will cause it to go into a tighter and tighter circle. At least that's the theory. Let's see if it does. A little bit more. A flat sheet, you can't really start it out bending too quickly. There we go. See, the tighter and tighter. I keep cranking it up. I'm down to 4 millimeters now. We'll just keep going to see if we can close the loop. A little more. Aha! Now we're getting somewhere. So you can't get all of that in one motion. You have to do it in a series of steps. So that's all we're doing. I'm adjusting the knobs in the back, bringing into play. Almost. Run it through a second time, tighten it up a little more. I'll show you a little trick to this in a moment. This should close this up. Okay, and it did. Now, I got to get it out. How are we going to do that? Well, first of all, we're going to lower back down that roller to relieve a little pressure. You have a latch here. So we back the latch out. There's a lever here. This should cam that up a little bit and release it. So you can lift this roller when you have a really tight spiral like this. Get your part out. And we just made a cylinder. Now, that could be a tank or whatever we wanted it to be. Doesn't have to be that large. Now, we have to put this back. Cinch that back. But all we have to do now is either weld that or bridge that, and we have a tube. And we can make a tank, an air inlet line, just whatever we need. This is a slip roller. It's for forming curves, hoops, and cylinders. Very nice tool. All right, here we are at the last section of part 1. And here I have a half-scale frame from a little gravity car done by another project. And I'm going to use it to show you probably the simplest way to create a body covering for a space frame. Now, this is made out of square tubing. The center section is a rectangle. Then you have slightly tapered on each end, and the top's the same as the bottom. Now, we could cut out sheet metal panels, then go from here, see this cross member here, to here, and attach them with screws. Same way on the bottom, we would definitely do that because on the bottom, you want to keep as flat as possible. You don't want any kind of curves on the bottom. You want to keep it flat. But on the sides, you might want something more than just straight metal, flat metal, flat metal. It would look faceted, meaning just flat planes. Now, this is one of the easier ways to do it and give it a little bit look of a curve without putting in a lot of time and a lot of effort into complicated body production. So I like to use, for small sheet metal parts, I like to use just file folded material, and this is just simple white poster board. Works great on this half-scale model, and if you need more, you can just overlap the edges, use masking tape, and increase the boards to get a piece as large as you want. Now, what we're going to do with that is this. Let's say we're going to create a sheet metal covering from here to here on this tapered nose, and we want the top to curve. So we can have flat sides, but a hoop here, because that would be the normal shape of the car back here somewhere. We'd want a hoop, and we would want it to go down, down, down like so. And we can do that with simple two-dimensional curves in a flat piece of sheet metal without getting into three-dimensional compound curves where the metal's curving in two directions at once. That's a whole nother ball game, and that will be gone over in part 2. But to create a two-dimensional curve, just take a sheet of paper and you wrap it around the nose like so. You pooch it up to get it as high as hoop as possible, or if you wanted to cut out a piece of board or a pointer here where you want it, and you angle it down like this. And you get some kind of clamps, clothespins if you don't have anything else. So what we're creating a hoop that's higher in the back. Clamp that down, the frame, and lower in the front. So we got extra material that's going low. So we take a pencil and we get under here and we mark and we mark and we mark all the lines. Mark all the lines. Take this off. Take some scissors and trim it out. Now to save time, I've already got one that's trimmed. Let's see if I can remember which way is what. Yeah, there we go. Yes. I'll just clamp it down quickly. Need to come a little forward. Let's just go ahead and stick that one on there. Worry about the others. Now this is better than just all flat panels. That looks a little frumpy. This isn't a super sophisticated body, but it's a little bit better. And you do have some curve on the profile. I'll turn it sideways to show you. So you have some tapering down here, but this is a straight line. There's no compound curve. And you could bring in the sides and attach it with blind rivets or sheet metal screws into the chassis itself, and you have a body coupling. Now you'll have to create a nose cone, but out of fiberglass or metal or something else that will create a nose, but you can carry this all the way down the length of the car very quickly, very simply, out of straight sheet metal. You use poster board to lay it out and make templates, because metal like this 1 millimeter metal on this table, that's $100 worth of metal. A skin covering that's 0.025 inches thick would cost about $60. If you make a miscut, you've thrown $60 away. If you make a miscut on poster board, you've thrown $1 away. So work it out in metal. Take this off. Lay it down on your sheet metal you're going to cut it out of. Tape it down, trace it out accurately, cut it out. Then put it on and attach it, and you got a body. That's the fastest, easiest way to do it. Now, I had it here with the sides being attached here and here, so the sides would be flat and flush. If you wanted to do something more exotic, you could do the same thing. Now here, notice how I push it out to an ellipse, or almost an ellipse. This is the way Indy cars were done in the 60s and even in the early 70s, is that a lot of them would have a chrome moly tubing space frame, and but they would be skinned with alloy to give them a really nice aerodynamic shape like this and provide room for air ducts and things like that. However, this is a heavier way to do it for two reasons. One, you're using more metal, that's heavier. Two, you have to provide some sort of skeleton structure, formers, that will create this shape for the sheet metal to hook to that's not normally there if you use the simple method like this, because you need no formers for this. So, if you want minimum weight, then go with something like this. If you want best looks, then you can create a rounded type body, even with a rectangular space frame beneath, but it will cost you more time and a little bit more weight. So it's your choice. So go do your project.